Alright, so welcome to the first part of today's lecture. Today is March 24th. We are still considering the example on page 273, example 273.1, in which the payoffs are given in figure 274.1. And what we're trying to do is use the definition of a Bayesian game. In order to define a Bayesian game, you need players, states, action signals, beliefs, and payoffs. And we're just going to define that game more formally. So you can see an example of how a game is to be defined more formally. The players in this game are the two people, player 1, player 2. The states are meet and avoid. So the states correspond directly to the type of player 2 is. So it is as if before the game starts, player 2 receives a signal that tells player 2 what her payoffs are, and player 1 doesn't receive that signal, so player 1 doesn't actually know what type of player 2 is. And so the two things, player 2 being of a particular type and there being a signal that tells player 2 what her payoffs are, those two things are equivalent. So the states are either meet or avoid, and the states correspond directly to the type of player that player 2 is. The actions are B or S for either player. In this case it's Bach or Stravinsky. The signal. So now the signal that P1 receives is a signal that doesn't disentangle, doesn't allow P1 to learn what the state of the world is. So it doesn't allow P1 to learn what player 2's preferences are. So this signal Z is exactly the same. Is seen whether the state of the world is meet or the state of the world is avoid. The signal function tells you what signal is generated given the state of the world. And here the same signal is generated irrespective of the state of the world, and so player 1 never actually knows what the state of the world is. Player 2, however, receives two different signals, M or V, and receives the signal M when the state of the world is meet, and receives the signal V when the state of the world is avoid, thanks to her signal function tau 2. And so player 2 will receive the signal and learn what her payoffs are, and player 1 doesn't. The beliefs are, so on observing Z, the probability that player 1 assigns to the state of the world being meet is 1/2, and the probability that player 1 assigns to the state of the world being avoid is also 1/2. On observing M, the probability that this is probability, the P with the two lines, that player 2 assigns to the state of the world being meet is 1. Also, this implies that the probability that player 2 assigns to the state of the world being avoid once M is observed will be 0. Right? So meet is the only thing that can occur if player 2 observes the signal M. Similarly, when player 2 observes the signal V, player 2 knows for sure with probability 1 that the state of the world is avoid, and player 2 will also know that the state of the world is not meet. So the probability that player 2 would then assign after observing V to the state of the world being meet will be 0. The payoffs are exactly as in figure 274.1, so you can look at the book for that. And the left part of the panel corresponds to the signal to the state of the world being meet, and the right part of that panel corresponds to the state of the world being avoid. So that's part 1, I'll send part 2 as well.